Hey, Chem kids. Okay, there's one more thing that we need to learn about ions before we can move on to learning about how these ionic compounds come together. And that is about polyatomic ions. All right, so what are polyatomic ions and how do we include them in an ionic compound's chemical formula? This is going to be really important information when we're making these formulas. So think for a moment about the roots of the word polyatomic. What does it mean when we say, when we put poly as a prefix on a word? It means multiple, right? And what is atomic? Well, having to do with atoms. So a polyatomic ion is actually a group of atoms, multiple atoms that are bonded together. We haven't learned about covalent bonds yet, but they have covalent bonds. Polyatomic ions are covalently bonded atoms that have an overall charge. Okay, so sometimes we're going to see polyatomic ions in our ionic formulas. And now when we're talking about, when we're sort of breaking down the structure of ionic compounds, we're not going to use polyatomic ions because I don't want to get too complicated on you, but I do want you to be aware that these exist and I want you to be able to identify them. Now, the good thing is you don't have to memorize them because they're on your reference table. Go ahead and get out your reference table and look at page 7, and we're going to talk about these polyatomic ions. Okay, so again, these are groups of atoms that stick together as a unit and have a charge on them. Okay, so most molecules, groups of atoms are neutral, but these are groups of atoms. They're like molecules, but they have a charge on them. Okay, so for example, phosphate. Here's something that I want you to notice. The formula is PO4, and the charge is -3. Do you see that? So this is a phosphorus atom and 4 oxygen atoms bonded together, and the overall charge on that group of atoms is -3. So when you are looking at these formulas on your reference table, especially, don't get confused by the subscript here, which indicates how many oxygen atoms there are in the ion, and the superscript here, which indicates the charge on the ion. Okay, we'll look at a couple more so you can make sure you're clear on that. This is carbonate. Its formula is CO3. It's carbon and 3 oxygens with a charge of -2. This one's called acetate. Okay, its formula is C2H3O4. It's got a charge of -1. On your reference table, I think that you're just going to see the negative symbol there. Okay, so keep in mind that in that case, the 1 is understood. You can write it either way, -1 or just negative. And I think that you might also sometimes see these, the numbers written differently. I'm looking at the reference table to see. Oh no, they say 2 negative, but you might actually see it as -2. Don't let that confuse you either. All right. So the names of these things often end in ate or ite. So that's something to pay attention to. If you see phosphate in a name, you know you're going to be looking for a polyatomic. If you see phosphide, that's just elemental phosphorus in ion form. Okay, so make sure you're making a note of what the ending is on your ion. If you're given a name and have to come up with a formula, that's going to be a thing that you're going to have to learn to do. All right, so again, this is on page 7 of your reference table, so don't freak out. You don't have to have these things memorized at all. They're there for you. You just have to kind of know when to recognize that you need to look for them, right? When you see that 8 ending, that's going to be the case. There are a few of them that don't end in 8 or ite. I'm looking to see. I think there's really only a couple on your reference table that you'll have to look at more carefully. All right, so a couple more things. When we are putting polyatomics into a formula, if there is more than one of them, you're going to put parentheses around them. So for example, magnesium nitrate, its formula is 1 magnesium ion for every 2 nitrate ions. So you can see there that it's MgNO3 in parentheses with a 2 on the outside of the parentheses to indicate that there are 2 of those nitrate ions there. Okay, so if you didn't have the parentheses there, it would just look like NO32, which is wrong, right? There are not 32 oxygen atoms in that case. So those parentheses help us to indicate, okay, there's two of these whole ions. We're not going to separate them out and say MgN2O6, but that is what that means, right? That 2 on the outside of the parentheses multiplies each of the elements in the ion, but really what we have are 2 of these complete structures. All right, and there's one other piece for this. You want to keep them separate if an ionic compound is composed of more than one polyatomic ion. On your reference table, there is only one polyatomic ion that has a positive charge, and that is ammonium. The rest of them are all negative charge. So you might see that ammonium at the beginning of a formula. It would look something like this, okay? NH4 is ammonium, and it's got a charge of +1. And hydroxide is OH with a charge of -1. Okay, so the formula for this is NH4OH. We are not going to do NH5O. This is to indicate that we have these 2 structures, these 2 ionic structures that have come together in a compound. And so let me know if you have any questions about that. I'll have some practice for you and a mastery check.